So first of all, I would like to thank everyone here to join this webinar. My name is Mohammed Ali Shrouf. I'm taking care of the product and solution in AIKO. And in this session today, I will be telling you about the most updated panels we started to produce in China. We call it upgraded Infinite series. So it will be the first 500 module under 2 square meters, and let's say in the industry. So we started the production in China, and it's expected to arrive to Europe and be available by our channels. Let's say mid of November. So as a content agenda for today's webinar, we will be talking about the upgraded Infinite series. Then we'll be talking about the key values of the ABC modules in general. And then we're gonna review case analysis, two case analysis, one for the residential segment, households, projects, small projects, and also another case for the commercial and industrial buildings. So starting, let's say, with the big picture of this new product and talking about the power output of this panel. To be more specific, I'm referring here to the standard panel length 1762 length and width 1134. This is the monoglass white backsheet. So the power will be 500, and you can see there's an improvement of 3.1% in terms of efficiency compared to our previous infinite panels, and 15-watt improvement. And if we compare it with, let's say, with the maximum power we can get from the mainstream technology in the market, TopCon, against the 470, we have 30 watts extra, and in terms of efficiency, it's 6.4%. So this improvement of the power and efficiency, will help the solar project to produce more energy and achieve more financial benefits. I would like also to highlight, maybe especially for the guys are joining AIKO webinars for the first time, that these panels also rely on the ABC technology. This is a technology we use in our cells. ABC stands for all back contact, where AIKO managed to place the electrical circuit from the back side of the cell, leaving the front surface completely free to utilize the sunlight. Just other technologies, as you know, they have electrical circuits on both sides, and normally they cover 3 to 5% of the cell surface. And this is a big improvement we have done in the back contact technology, and open the window to increase the power output and also achieve other features we will be going through this webinar. In this part, we will be talking about the key values of the ABC modules, and I would like to categorize these values in big 5 families or groups: high power, and the other one high technology, the third one high aesthetics, high reliability, the fourth one, and finally high returns. Basically, you can do more money with the efficient solution. So the updated Infinite series will be covering these 4 panels. So we're talking about the panels based on 54 cells. So this is the dual glass full black panel, and the maximum power of this panel will be 490. With an improvement of 15 watt against our normal AIKO panels, and 30 watt more against TOPCon. Also, we have the monoglass white backsheet, the same output and the same improvements we have against other technologies. And also we have the white bag sheet, two versions, the monoglass and the double glass version with a power up to 500 watt. I would like also to emphasize that especially for the full black panels, both virgin mono and double glass, we have increased the warranty for only the power classes of 480 and 485 and 490. So in the future, if you buy these three power classes, 480, 485, 490 full black panels, it will be by default having 30 years of product warranty and 30 years of performance warranty. So this is a big advantage for the end user. Also, these panels will have the old features we gonna review. We used always to inform you about the partial shading optimization, the temperature control, and the micro crack resistance. It's also good to mention that all these panels will have the original MC4 connectors from Stobli. So this is a basic, let's say, standard in European market, and yeah, we always offer these panels with these connectors. Talking about the high technology we use in our panels, especially in the I'm talking about here the Infinite series. Our motivation was to reduce, let's say, the non-cell area in order to increase the power output. And the first step we have done in this direction to fold the ribbon on the backside, and in other words, the string collectors. Here in this video, you can see how we managed to fold, these ribbons. Normally, you have at the top of the panel, in the middle, and at the bottom edge. So we managed to fold them on the backside, and this kind of folding process helped us to increase the effective power generation area by 1.4 percentage. When it comes to, let's say, traditional technology, this is quite challenging because they have the electric circuit on both sides of the cells, and in order to do continuity, they need to fold these ribbons, and this could be a potential of a micro crack, especially at the edge of the cell. So that's why we don't see other technologies are going in this direction, and this, let's say, kind of an advantage for the back contact technology. The other also improvement we have done in order to reduce the non-cell area was to overlap the cells, as you can see here. As you know, the cells has small horizontal gaps, and what we have done, we overlap these cells, and this also improved the effective generation area by 0.4 percentage. We have seen this approach in the industry, firstly by the shingle technology. So in the shingle technology, they use conductive adhesive material, but it shows an issues in terms of reliability, especially for after 3-5 years in terms of the thermal cycle, like summer and winter, the conductivity of these adhesive materials getting less. And the industry has realized a huge drop in the power output of the solar panels. And again, this can be done for the traditional cells, but there's a huge challenge again due to the electric circuit, because it's on both sides, and this will cause there will be a high potential to have micro cracks at the edge of the cells. So again, this is, I would say, a big advantage for the back contact technology, and it helped us to improve the power output of our panels. Talking about the technology, also we have in our panels, I would like to highlight an improvement we have done, and this is especially for the back contact, let's say, for the back contact technology. So back contact technology has long been seen as the most, let's say, promising pathway to achieve the highest efficiency in the solar industry since a long time ago, since 1975 actually. But it was not possible because the manufacturing process of the back contact technology is kind of complicated, and that was always the issue till, let's say, 2021, 2022, when AIKO delivered a new approach. We call it two-step innovation, and this helped us to, to crack the back code of this technology and make let's say a commercial panel out of it. So just to understand what's the difference between the one-step process and two-step process, we need maybe to dive a bit in the technology and more technical stuff. So for the one-step process, normally in the production line, after we do the wafer washing, and then we do the passivation for the full wafer, for the full cell, the entire cell, we do the passivation. Then we do the insulation in order to prepare for the, the P and N junction, the two different zones. And then we do the doping. We use the phosphorus and boron to have, at the end of the day, P and N type junction. And the thing here I would like to emphasize that we do the passivation for the entire wafer at one shot, and we kind of compromise because we don't do it for each region separately. We do it for the entire, or let's say they do it because we have the other way around. We do it in two steps. So there's kind of compromise in terms of passivation here. And what AIKO has done, they just separated these two steps of passivation. So after washing the wafer, they do the passivation for the wafer, and they form the P junction normally by doping the boron. Then they do entire here insulation using the laser, and then again one more time they do passivation from scratch, and then forming the N type, the N region in the cell. So let's say this kind of two steps of passivation give us improvement on the efficiency and power output of the panel. And this is the main development we have, and give us an advantage to make one step further in the back contact technology. Talking also about the high technology, we always talk about the partial shading optimization we have in our panels, and this is a big advantage where you can get basically more energy out of the PV system and enhance the financial benefits. And it also has benefits in terms of operation and maintenance, because you're gonna see we less activate the bypass diode, which is a crucial part in the solar panel. So in this video, we can see a demonstration how, let's say in this case, this is the chimney dynamic shading, how it affects the panel normally, and how you lose part of it. So the main advantage we have that we don't activate the bypass diode for a small shading like that. Unlike the TOPCon panels, if you have a few cells or one cell get shaded, the bypass diode will get activated, and basically you lose this entire block, which is not the case for AIKO. So in this case, you lose 44% of the panel, but for the top con, basically you lose the entire panel. And also you can accumulate this negative impact on the entire string of that shaded panel. Another also example we can see due to the tree shading here. So this is the AIKO panel. You can see here when you have a few cells shaded, the bypass diode will not kick in and you just lose 41% of the energy of the power output. But for the TopCon, the second also bypass diode will get activated and basically you lose two-thirds of the panel. And even if you have a very small object causing the shading, like leaves from the trees, as you can see in this example. So for the TopCon panel, you just lose the shaded cells, in this case only 6%. But for the TopCon technology, this bypass diode will get activated and you lose the entire blocks. So again, this is a big advantage to improve the energy yield of the solar system and improve the financial benefits. We have done some testing environments, as you can see in these below examples. One just to show the near shading scenario impact, and ABC solution showed an improvement of energy of 7% compared to TopCon. Another example, due to the tree shading, showed a 12% improvement. And for such dynamic shading, if you have a chimney or a fixed object close to the panels, the improvement could reach 50%. So I would say it's always good to have these panels that could help to increase the energy output and enhance the financial case of the solar projects. I would like to talk also about the high aesthetics we have in our panels, and since we don't have any electrical circuit on the front side, we were able to improve the appearance of our panels. Here you can see the blackness difference between the ABC panels and TopCon. And due to the fact that we don't have fingers and we don't have bus bars, or we don't have cell spacing for the infinite series, this help us to improve the appearance of our especially black panels. So this is always appreciated by some end users, and yeah, this is luckily an advantage for the back contact technology. Um, I would like also to talk about the big umbrella here. We have the high reliability of our panels, and maybe it's good to know that one of the major challenges we have in the solar industry, it's the micro crack. Normally, these micro crack, it's like happens at the edge, at the surface of the cell. It's very tiny, small. Even it's hard to see with your eyes, and normally you need the thermal camera to find them. This normally happens during the shipment, during the installation, snow and wind load. So let's say this is a big challenge we have in the solar industry, and AIKO was trying to investigate to improve this part. And in order to know how we could how we have managed to move one step forward, it's I think it's good to know that 90% of the panels you see in the market, they use silver in their electrical circuit. And that was, let's say, the start of the development. And we thought, let's use the copper instead of silver. So basically, our panels, they don't contain any silver. We use copper instead. And using the copper actually help us to do three upgrades here. The first upgrade on the material level. So the copper is way stronger compared to silver. The other also upgrade we have on the process level, because we use electroplating in order to place the copper circuit. Unlike, let's say, the silver technology, they use laser in order to do the sintering, and normally using the laser will cause a heat dissipation on the wafer, which will affect the wafer negatively, and this normally can be seen after a few years of the performance of the panels. Also, we have upgrade on the combination of the electrical circuit, because we have seen in the industry a few TOPCon panels, they try to combine copper and silver, especially for the ribbon they use now copper, but still for the bus bars they use silver, and in our circuit we use the copper. So let's say these are the three upgrades we have done in terms of electrical circuit. Also, I would like to highlight that when it comes to the back contact technology, we do the soldering between the cells only from the back side. And even though if there's a potential of micro crack, still we maintain the connection between, we maintain the connection in the circuit. And for the TopCon, since they have it from both sides, and then they need to use kind of a Z shape soldering just to continue the circuit. And if they have let's say a severe crack, so we have done a test just to see what's the impact if you have such a severe crack. We have seen that with the ABC technology, the loss is only 18%, while for the TopCon, the loss in the electrical output is reaching 42%. So again, this is also a big improvement in order to reduce the risk of the microcracks and enhance the energy output of the solar system. Also, talking about the reliability, I would like to mention that recently we have seen most of the monoglass TOPCon panels are disappearing from the market. This is due to the reliability issue. But in our case, we can still produce both types, mono and double glass, because we don't have the real reliability issue that that the industry has witnessed for the TOPCon technology. So for the monoglass panels, we use a 3.2 millimeters glass thickness, and normally we have passed the 40 millimeters health test performance. And for the double glass panels, we use 2 millimeters glass thickness, and we have passed the 35 millimeters health test performance. I would say majority of the TOPCon panels nowadays in the market for the double glass panels, they use 1.6 millimeters, and this is a downgrade for the hail resistance, and also in terms of mechanical load. So this is also another advantage we have in our panels. Also, I would like to highlight that when we talk about the double glass panels of AIKO, all the double glass panels, they have fire class A according to the IEC standards. And this is also a big advantage, and it could be a key to close and win some projects with high requirements, especially with some I have at least witnessed with some governmental projects, they have high requirements. Also, we have kind of a temperature control in case there's a hotspot. So imagine if you have tree leaf laid down on the panel for a few hours. Normally there will be a hotspot, and AIKO panels has a chance to reduce this risk by at least 30%. So the temperature normally doesn't go too high. It's reaching up to 100 degrees, but for the TOPCon it goes up to 150. This is again due to the partial shading optimization, where let's say the electrons keep flowing and doesn't combine on that weak point, I would say. So this is also a big advantage in terms of safety, and it helps to reduce let's say the fire risk. It's very minimum, but it could happen, and this is a big advantage for the back contact technology. Also, I would like to highlight these two features that could help the owner, let's say, of the solar project to improve his financial benefits and returns. The first one is the temperature coefficient. So the value we have in our panels is 0.26 percentage per degree. So compared to TopCon, it's 0.29 percentage per degree. Normally, you can find these coefficients on the data sheets of the panels. And yeah, normally when the panels are in operation, the temperature of the panels can easily reach 60 degrees, and um, this give the ABC solution an advantage of 1.1 percentage in terms of yield and energy output. Also, another feature could help to increase the return is the lower degradation. So, as you know, the panels, they have a nameplate power. So, for example, if you buy the 470, after a few years, it's not 470 anymore. There's a small degradation happens year by year, and we have an advantage on, let's say, on the degradation from the second till the 30 years. It's 0.35 percentage. So compared to TopCon, it's 0.4 percentage. And if we look to the power output of the panels after 30 years, we can see that the AIKO panels has a 1.5 percentage more power. So this is again a big advantage to increase the energy output of the system over the lifetime and enhance the financial benefits. At the end, I would like to talk about the case analysis for both segments. So let's start with the residential, let's say, case, and it's always important to know why it's important for the end user to invest and buy efficient panels. So for this example, we're talking about two adults and two kids house. They consume the typical consumption here in Europe, something around 8,800 kilowatt hour. And we would like to see the comparison between the two options. First option, to use efficient panels from AIKO with power output of 490 watt peak, and the other option to use the 460. This is, let's say, the maximum TopCon panels they can find in the market. And we go with 20 panels for this system size, and we can say that using the efficient panel will help the end user to increase the generation unit, or let's say the DC capacity of the PV system, with 6.5 percentage. So this is a big advantage for him, because having a bigger system on his roof will help him to increase the energy output. And even though he invests more money as an initial investment, in this case something around 850 euro, well, the payback time of the project will be shortened. Basically, he's generating more energy day by day during the operation of the project. And also, if we consider 30 years of operation of the PV project, we're talking about 14.5 percentage of extra green energy he can gain due to the improvement on the system size. And in the money language, it's equivalent to 8,300 euro. So it's a win-win, let's say, case for him to invest extra money at the beginning of the project. Basically, he's buying a bigger system, and he's getting more benefits during the operation time. So this is, let's say, the idea behind using always efficient panels and guiding your customers to go with efficient solution. Um, for the residential, for the commercial, let's say, case and values, I would like always to look to the commercial business from two different angles. One angle from the EPC or the installer angle, and one time from the owner of the owner of the project angle. So from the APC side, uh, let's think about let's say the basic the basic thing of the project. Normally, you charge, let's say, your customer on the kilowatt peak of let's say of the system. So, for example, if we assume you're gonna charge the customer 750 euro per kilowatt peak, and by using efficient panels, you can basically increase the system size. In this case, uh, the system can be increased by 6.4%. It means you can increase the revenue because you charge again, you charge the end user on the kilowatt peak level. So if you increase the system size, you can basically achieve more revenues. Um, and if we look to the cost, for sure you're gonna invest more in the efficient panel because basically you buy a bigger system. But on the other hand, if you look to the rest of what we call like the balance of system, the mounting system, the cabling, the labor hour to deploy the project, also the operation, you need some lifts, some stairs. Everything will be the same, right? Because basically you provide the same number of panels, and this will help you to increase your profit. So in this case, you're gonna increase your profit by 11%. So this is the idea behind let's say offer to the end user efficient panel. It's always good to use efficient panels at an early stage of the project, because if you just jump to the project on a late stage and then you have a limited budget, it will be hard for you to invest even with an efficient panel because it will cost you more. So, but if you could manage from the beginning to communicate to the end user the values and the benefits of the efficient panel, it will help both of you. You can make bigger revenue, and he will also make more financial benefits. So, talking about the end user, normally I'm also referring here to the previous example here. So basically, with the efficient panel, he can improve the internal rate of return by 7.7 percentage. And maybe I forgot to highlight that we are comparing here the 500 watt panel from AIKO against the 470 watt. So even if you do the comparison against lower, let's say, TOPCon power output like 455 or 460, all these indicators will get improved. Also, he will be shorten the break even point or the payback period by a certain time. So in this case, he can shorten the time by 3 months. And also he can again increase the extra green energy he can produce due to the bigger system with, in this case, 80 megawatt hour. And in the money language, we're talking about 335,000 euro over the 30 years of operation of the project. So it's always a win-win case for the end user to go with efficient panels. The only thing he should consider in his mind to increase his investment, the capex, and most of the time they use financing systems like bank loans to finance these projects. So I would say this is the benefits for both parties, the household owners and also the commercial building owners. I think I'm done with my presentation. So thank you very much, and maybe I leave the ground to get some questions maybe from your side. So if you have any question, just feel free to write something in the chat. Let me just see. So yes, we can send you the presentation. One question, yeah, from Suko. Yeah, we can share the presentation with you. The only thing we have, it's the big videos maybe we have, it will be huge. So maybe we're gonna use a transfer link, or we gonna manage that. Sounds good. Thank you. It's perfect. Yeah, someone is asking about the availability of our panels. Yeah, it's expected to be in Europe, let's say mid of November this year. So it's in the production nowadays in China, and we will ship them soon. As you know, 1.5, 2 months on the sea journey, and then you have it by the distributors. So I'm not seeing new questions in the chat. I think low carbon will be, yes, I can see now few questions are coming. Yes, for the France market, for the French market, we offer these panels with low carbon footprint. Yeah, we know it's an essential requirement for the French market. So it's it will be available. No worries on that. Uh, one question from Gabriel. He says, how high do you think the ABC technology can go, and will you be looking to? Let me see the full question. The technology. I think you're asking about the perovskite. So we are doing some research and development, research in this path. But as far as I know, still the perovskite is not reliable. And yeah, we will keep doing our research till find a way to improve, let's say, the efficiency. But in general, let's say, in order to increase the power output or the efficiency of the panel, in other words, you can investigate in two things: how to reduce the optical losses and the electrical losses. So any improvement in these two major things, you can make step forward in terms of power and efficiency. I don't see more questions. I think we have reached the end of this webinar. So if you have any question, just feel free to send it to our email. And yeah, if you would like to get more details, you can always reach the local team, because we have, let's say, a technical support for each region in Europe. I'm normally taking care of North Europe, but we have also dedicated technical support for each region in Europe. Thank you very much, and yeah, stay tuned for the upcoming webinars with AIKO. Have a nice day. Thanks.